linked list number 1, which is our odd linked list, and we have linked list number 2, which is our even linked list. So after even reaches here, so outside the while loop, we have this state. This is the state we are in. Hi everyone, welcome to my channel Code with Ease by Varsha. So these are the questions which we are already doing as part of the linked list playlist. These are the questions which we have already done so far. Today we will cover the odd even linked list, and these are the companies in which this question has already been asked. So this question is more of like a reordering of a linked list. Let's take a look at the problem statement that we have. So we are given the head of a single linked list, and we have to group the nodes with the odd indices first, followed by the nodes of the with the even indices. Remember, it's about the indices. It's not about the values of the nodes. So here the first node is considered as odd, the second node is considered as even. If we take a look at this example, so although the values that you see here at the odd indices are also odd values, but it's not about the values in the nodes. Remember, it's about the odd indices, which means 0th. What is the first node? I mean, what is the first index? Usually in case of an array, we say 0. 0 is an even number. So let's forget about that. Let's say the first index in this case is 1. The second index is number 2. Third index is 3. So in that way, what we are doing, all the nodes at the odd indices, that is 1, 3 and 5, are being placed at the first. Then you group all the nodes at the even indices, and then you group them at last, and then you attach both. So first you have the odd indices, then you have the even indices, and then you club them. I mean, odd indices node and the even indices nodes will be clubbed together, like they'll be merged. So we have to understand that the relative order should remain the same. It should not be like 1, 5, 3. 1 first, then 3, then 5. We have to maintain the order, and we need to solve this problem in constant space and linear time complexity. So if we take a look at this particular example, what we can see is, like I said, 1, 3 and 5 are being grouped together and then followed by the nodes at the odd, the even indices. First the odd indices and then the even indices. So what is the resultant output is 1, 3, 5 and 2, 4. If we see the second example here, again the numbers are shuffled. So don't go by the numbers. Think of it in terms of the indices. Here 2 is a number which is even, but it is an odd index. So 2, 3, 6 and 7 are grouped together, followed by 1, 5, 4. That is why the colors are also given in that way, so that it's easier for us to understand. So basically, we have to reorder the linked list. The ordering of the nodes has to be redefined, and that is what the algorithm we have to write for today. So let's move to the whiteboard to understand what can be the approach for solving this question. Okay, so this is what we have to do, right? So we are given this is the input that we have, and this is the output that we have. So 1, 3, 5 followed by 2 and 4. So what can be the approach to solve this in the given time complexity that we are having? Linear time complexity and constant space. We are not supposed to use extra space. So why is this being given explicitly that you are not supposed to use any extra space? Because the brute force or the naive way of thinking would be, let's traverse the linked list, let's pick up the nodes at the odd indices, let's put it inside some data structure, probably ordered data structure like a linked list. Okay. Sorry, an ordered data structure, maybe like an array list, because the order has to be preserved. So we'll put it in some ordered data structure, and then we'll again go through the linked list again. Second traversal, we'll pick the nodes at the even indices, we'll put it in the ordered list, and then we'll merge it together. So that 1, 3, 5 is in one array list, 2 and 4 is in another array list, and we'll traverse through the extra data structure that we've taken and link it. I mean, merge both of them together. That can be like the very first brute force way, because we don't want to play with the pointers. We just want to take some additional space and store our required values, and ultimately we'll just have to merge it, right? So that can be the initial thought process, and that is why they have specified in the very beginning that you have to do it in constant space. You're not supposed to take any additional space. So what will be the approach for solving this question? Okay, see, couple of things. If we only pick up the indices that we have at the odd indices, if we pick it up, we also have to make a point that we attach it with the nodes which are being, I mean, with the linked list which is being formed by the even indices. This is the even linked list and this is the odd linked list. So there's a point which we have to think about, that we have to attach these two. So that is the end result that we have to do. So two things are very clear. The odd and the even should be attached. I mean, the odd linked list, the sublist, the odd sublist and the even linked list have to be attached at some point to give us the required output. The second thing which we have to understand is, we have to do it in linear time complexity, right? So it cannot be that we first do one traversal and then we do one traversal, and then inside one traversal we will again do a traversal. All of that is not possible. Basically, we cannot do multiple exponential, like O of n square traversal is not allowed. We have to do it in single traversal, and when we have to do it in single traversal, we have to play with the pointers. Okay, so how can we play with the pointers? Now, people who have done two pointers algorithm, or people who have done fast and slow pointers, will be able to relate that what do we really need? We need the nodes at the even indices, we need the nodes at the odd indices. That's it. So if I have two pointers, one is the odd pointer and another is the even pointer, I will move the odd pointer in the sense that it will only hop from one odd node to another odd node. The even pointer will also hop from one odd node. Sorry, the even pointer will hop from one even node to another even node. That is it. That is what we need to do. So what we can do over here, simply let's say I will have one odd, I'll call it like the odd pointer over here. I will add an even pointer over here because this is the odd node, this is the even node. Now what I need, once the odd pointer is over here, the odd pointer is pointing to 3. 1 is pointing to 3, which is nothing but the even dot next. So 1 is pointing to 3 side. So if my odd has to point to even dot next, what will I write? I'll say odd dot next will point to even dot next. So what I meant by that point of hopping is now odd is pointing to even dot next, which means 1 is now pointing to 3. Now the odd pointer can hop from 1 to 3. How will it hop from 1 to 3? I will just say odd is equal to odd dot next. What is odd dot next? 3. So I will safely remove my odd pointer over here. So it has hopped from 1 to 3. Similarly, what will be in the case of even? Now odd is over here, even is over here. 2 needs to point to whom? 4, which is nothing but odd dot next. So I will just say even dot next is equal to odd dot next. So see how both the pointers are trying to complement to each other. Even is helping the odd to find its next node. The odd is helping the even to find its another next node. Similarly, even will also hop from 2 to 4. So even will go to even dot next. Only this much is the main code that you have to write. This is what will happen inside a while loop. Hopping of the nodes. I would say this is the hopping from odd to new odd and from even to new even. So if we are able to do this, then simply in linear traversal, we'll be able to complete. Similarly, now what will happen? Now our even would have come over here. Next, again, odd is equal to even dot next. Again, the odd will move over here and even would come to even, like even would eventually come to null. So basically, even node will reach the null first. So that is why we have to write in this condition when we write over here the while loop that even should not be null. Like we just write that condition, right? The even should not be null and the even dot next should not be null, because the first thing that is happening is the odd is being pointed to the even dot next. So even dot next should not be null, and even before that the even pointer should not be at the null. Otherwise dot next will throw a NP. Okay, so this is the main code which will run inside the while loop, right? Where we will hop the nodes from odd node to the new odd node and from the even node to the new even node. So if we do a dry run now, so let's quickly do a dry run by doing the hopping and reframing our inputs. So we have our odd node here. Sorry, I'll take a different color pen. So we have a odd node here and we have an even node. So what I said, odd will point to even dot next. So 1 is pointing to 3. Odd comes over here. And even will point to odd dot next. So we have a separate chain. 2 is pointing to 4. So now even will go over here. Now odd will point to even dot next. 1. Now 3 will point to 5. So odd will come over here. And even will point to odd dot next. So it will point to null. And even will go to null. Once it reaches null, our loop is complete. So we have linked list number 1, which is our odd linked list, and we have linked list number 2, which is our even linked list. So after even reaches here, so outside the while loop, we have this state. This is the state we are in. So remember the second point, the point which I had told that this B point is done. We have able to play with the pointers, do it in single traversal. Now the joining, the attaching, these two has to be attached. We have independently created two linked lists as we needed. Now we have to attach it. Attaching might look very tricky, but it is not that tricky. It is very simple. What is your odd? Okay, but whatever be your linked list, the end of the odd linked list will point to whom? It will point to the first even node or the node at the even index. So why not store this the first even node in some pointer? So when we had placed our odd and even pointers, initially our odd was here and our even was here. We were saying head equal to no, odd, and then whatever the head dot next is, it will be even, right? So if that is the case, we can also store one more pointer over here. We can store one more pointer over here, and we can say that even head, which will point to this even head, because this is the head. The second node of the linked list will always be the head of the even linked list. I don't care about the value. Now it is 2, it can be 31 also, but I care about the nodes, the index of the node, which is an even index. So even head will always point to the next node, the second node. So if I store my even head, what can I do at the end? Eventually, when my odd reaches here, which is at 5, my odd is over here, my even is at null, my while loop has completed, I can safely say odd.next is equal to even head, because your even pointer has reached the null. Now there is no point in doing odd.next equal to even, because even has gone through the end of the linked list. Now your even head is going to give you the reference of where it should point. So now if I say odd.next equal to even head, so 5 will be pointing to 2. So if that happens, my result is 1, 3, 5. 5 is pointing to 2, 2 is pointing to 4, and 4 is pointing to null. This is my final output. That's it. So what are the things, just to summarize, what are the things we need? We need couple of pointers from the very beginning. We need our odd pointer. We need our even pointer. I'm just writing in caps. You don't have to write in caps. And we need the even head. 3 pointers we need. These two will do the actual traversal, and even head will just store the even node which it has to eventually be pointed to by the end of the odd linked list. These 3 nodes we need. We need a while loop to do the traversal. The logic of this is already given over here, this highlighted portion. This is the logic which will go inside my while loop. And at the end, we just have to join our odd.next equal to even head. We don't have to return anything as such. It's just a reordering of the linked list. So I'll show the code now, the Java code which we have written. These are the steps that we have to do. That's it. So we need the pointers, we need the while loop, and finally we need to do the attaching. So I will show the code now. So this is the code that we have written in Java. So first we do the edge cases testing. If head is null and if there is only one element, we'll return the head itself. Now we initialize the pointers. So I have written it as odd current and even current. This is the same as what we discussed as odd and even. First odd will be at head, your even will be at head.next. Your even head is nothing but same as where your even current is, or the where we saw the node number 2 is. The first point, the first even indices, the first even index is going to be pointed by the even head. Then we start the while loop traversal. Like I said, the even node or the even pointer is going to be staying ahead. So that is what we have to check if it is not null, and the dot next is also not null. And here 4 lines of code just to do the hopping, where odd dot next is equal to even dot next. Odd is hopping to the next new odd node. So I've written all of that with the necessary comments also. Now this code will be available on the GitHub when the video is live. So don't worry about that. This is the while loop. At the end, what we are doing, odd dot next equal to even. Same as what code we have written over here, right? And finally, here we are returning the head because there's a return type of a list node which we have to return. But ideally, in case of a reordering, you don't have to return anything. Sometimes the head is, because the head is unaltered, is what I'm saying. Because the first node is your odd node. The first index is your odd index, and that is where the node is. So your head is technically remaining unaltered. So in this case, you have to return it because your head is anyway not getting, because in this case, because they have to return some list nodes, we are returning the head itself. So because the head is anyway not changed. So yeah, that is about this. Code will be available on the GitHub, and most importantly, we have been able to solve this without taking any additional space, and we have been able to do it in linear traversal in one single traversal. We didn't have to do any 2 traversals also. So yeah, that's about this code. Thank you so much for watching today's video. Please subscribe to my channel if you haven't already, and don't forget to like and share so that we get a lot of motivation to bring out more Leetcode questions like this in the future. Thank you so much.